Hello, my name is Aaron Walsh. I'm the director of the Immersive Education Initiative, and today at the 2010 Boston Summit we'll be showing a prototype of what we call web-to-world tools that were developed by the Library Technology Working Group in the Immersive Education Initiative. The concept behind the web-to-world tools is quite simple. It's the notion that not everybody needs to be able to create content inside the virtual world. Using a standard browser would be sufficient. What we're going to show today is an example of one type of web-to-world surface. These are square surfaces, but the surface can be any type. Images can be uploaded from the end user's computer, or they can be collaboratively constructed using what we call the audio whiteboard. We're going to launch the audio whiteboard now, which provides students and teachers an opportunity to collaborate using voice chat and also a shared whiteboard. The audio whiteboard runs in any standard web browser. Here it's running inside of Apple Safari web browser, and it supports the ability to drag and drop PDF documents directly onto the whiteboard surface. Here's a field notebook about the Maryland blue crab. Once a PDF document is in the whiteboard, the student or teachers can page through it, and everybody sees the same thing. The important part, of course, is the ability to collaboratively edit a document. And here we see examples of students that are examining the document. We can see that one student is interested in the fact that the scientific name stands for beautiful swimmer that tastes good. The student names are all associated with their individual cursor, so the teacher can tell who's looking at what and who's doing what inside of this collaborative environment. We're now going to see a group learning exercise where the students are called upon to highlight certain parts of the crab that they're supposed to know and to provide the labels. This student has correctly identified the pincher part of the crab, but they've misspelled it. And so the teacher is going to take that and correct it live in real time for everyone to see and delete the mistaken word. The rest of the students are then called upon to identify different parts of the crab's anatomy. And in this example we see that there is a dynamic back and forth between the teacher and the students as they interactively label and explore the different parts of the crab. This is happening in 2D, however, but it does afford us the opportunities for very high resolution imagery. In this example, the teacher uploads a high resolution photo of the crab and then quizzes the students on what they've just learned to see that they can in fact identify and properly label the parts of the crab that they're supposed to know. Once this is all done, or at any point actually, the teacher can publish into the virtual world what's on the whiteboard. That's the significant step here. This is a web browser outside of the virtual world that anybody with some basic familiarity with the World Wide Web can utilize. But not everybody can publish 3D content. Now using the Web-to-World tool, with a click of a button, the content that we see here on this whiteboard can be pushed into the virtual world. By clicking on the picture that looks like a camera, the imagery on the whiteboard is pushed into the virtual world. And here we are back in the virtual world with the students, and what was on the whiteboard now appears on that web-to-world surface. The students and the teacher further examine what they now have in the virtual world, and the important concept here is that virtual world content no longer needs to be authored by 3D content developers. Anybody that has a web browser can publish into the virtual world, and those images can be hyperlinked as well to anything on the internet and also to in-world locations, allowing for dynamic teleporting in and out of the virtual world. In addition to allowing collaborative spaces, web-to-world surfaces can be used for personal spaces. Here we have examples of web-to-world surfaces that have been arranged in personal spaces to give learners and teachers the opportunity to organize and manage their own collections. Because any image can be placed on a web-to-world surface, it can come from the hard drive, it can come from the World Wide Web, or it can come from a collaborative experience such as we just saw on the audio whiteboard. It gives learners and teachers the opportunity to put anything that they'd like visually into the virtual world and then to hyperlink that to any resource on the internet, and also, as mentioned previously, to in-world locations to allow teleporting. Here we'll see an example of a web-to-world surface that has been linked to a NASA paper. The avatar touches the surface. The web browser then loads that resource, and the individual can begin to read it and examine it just like any standard web page, because that's exactly what it is. Surfaces can also be linked to videos, and in a moment we'll see an example of a web-to-world surface that has been linked to a NASA video that is part of Rocket World. Once again, the user simply touches the surface, and in this case, a video loads.
Final launch readiness poll. VM.
VM is go.
PLC.
PLC go.
PCC.
PCC go.
PC.
PC go.
FTS.
FTS go.
OTM.
OTM go.
GNC.
GNC go.
Ignition. We have ignition. We have liftoff.
Liftoff confirmed.
Copy liftoff.
Web-to-world surfaces can be arranged in any configuration. We have a basic learning space configuration shown here, but they're colorized because this space is used for elementary school students. In this example, the South Park Elementary School students have been assigned as teams, and they share their personal spaces. So what we see are numbered teams here, where members of those teams can go in and associate imagery and resources to the web-to-world services that are in their group space. And here we have a collaborative space where the teacher and all the students can change the content on the web-to-world services, giving the notion of a collaborative space for the teacher and the students to work together, and then personal spaces for the students themselves. Although the Immersive Education Initiative's Library Technology Working Group has so far focused on rectangular web-to-world surfaces, it's important to note that our work is now carrying forward with three-dimensional complex shapes. So you can imagine that anything in the virtual world can be textured or wrapped with an image that comes out of world. What this means is that anybody with access to a web browser can construct and build three-dimensional content using just the web browser. No 3D authoring experience, no virtual world authoring experience would be necessary. The prototypes will be further refined over the coming year, and we invite your participation. Simply visit immersiveeducation.org and join the Library Technology Working Group.